Hi, my name's Greg Lecheminot, and I'm from Keysight Technologies. Today I'm going to talk about how to test an 800G transceiver and what that test system would look like. Even though there are no standards to support it yet, companies are already moving from 400G to 800G. And in that 800G transceiver, you're going to have 8 lanes, each with a 53 gigabaud PAM4 signal. Just as in 400G systems, the primary specification showing the quality of a PAM4 transmitter is TDECQ. Test engineers need a system that can test all 8 lanes quickly, accurately, and repeatably in a single system that's easy to set up, easy to visualize, and easy to control. Internal system timing of the 800G transceivers can vary, sometimes with one PLL for all lanes, or with an individual PLL for each lane. So the test system needs to have a flexible clock recovery system to extract clock and synchronize the test system. Keysight participates directly in industry standards, so measurements like TDECQ and more recent measurements such as PAM4 overshoot and undershoot, or the OpenEYE MSA mask test are defined and refined using the Keysight DCA. You can be completely confident that your measurement results are exactly what the standard intended and are often available to you before the standard is even published. The DCA-M series of oscilloscopes is very flexible, and the Flex DCA user interface can be used to control multiple DCA-Ms so that 8 channels or more can be measured in parallel in a single test system environment. DCA-Ms are also available in a variety of configurations, which include both optical and electrical measurement channels, as well as with integrated clock recovery. Which DCA-M solution is right for you depends on your application and your transceiver timing architecture. The test system needs to be synchronized to the transceiver, and for the 800G DUT we're testing today, one clock recovery is used for lanes 1 through 4, and a second clock recovery for lanes 5 through 8. This could be implemented using 2 4-channel N1092Ds with 2 N1078A clock recovery instruments, but we'll be showing a lower cost solution based on 2 2-channel N1092Bs with integrated clock recovery and 2 2-channel N1092Bs without clock recovery. It's important to note that the intrinsic time-based jitter on the DCA-M is only 160 femtoseconds typically, which is the lowest in the industry. And the clock recovery system can operate on NRZ or PAM4 signals between 150 megabaud and 64 gigabaud. The TDECQ test method for 800G is identical to what is used for 400G. Flex DCA controls the measurement hardware and is an extremely easy to use interface that in this case has been configured to perform TDECQ as well as several other key measurements on all 8 channels at once. The TDECQ functions are currently configured according to the latest IEEE 802.3d specs, but they can be easily reconfigured and customized. We'll click Auto Scale to launch the parallel measurements. The instrument will automatically lock clock recovery, perform an auto scale, acquire data on all 8 channels, optimize the equalizer taps of the virtual TDECQ receivers, and report the TDECQ and other measurement results. As shown, the DCA is able to perform fast, reliable, and accurate TDECQ measurements on your 800G designs. Also be aware that we continue to invest in innovative solutions that are going to lower your overall cost of tests. So please contact your local Keysight rep to get the latest information and have a great day.